Okay, Year 10. Today's lesson, we're going to start off with a starter activity. So I'll read through the starter activity for you so that you can write these questions down, stop the presentation and have a go at them. So, calculate 4 multiplied by 2 and 8 divided by 4. Second example, 10 added to a bracket 4 minus 6 all squared. Expand 8x, and then you've got a bracket with x plus 2 inside the bracket. Then you've got two brackets, x plus 3 and x plus 2, multiplying the two brackets together. Evaluate 3 cubed, 3 to the power of 3, or 15 squared, 15 to the power of 2. Factorise, you've got 15x minus 5y. Factorise, x squared plus 2x, take away 24. Solve. So don't forget, this is where you've got to get a value for x. They're equations, so you've got to get a value for x. 12 equals 5x plus 7. 5x take away 11 equals 2x plus 4. Then the last example in your starter, calculate the value of the angle x inside this triangle. So if you'd like to stop the presentation now, write down those examples, and then you can have a go at them, and then when you turn the presentation back on, you should have me actually going through the solutions for you. Right, so the solutions, Year 10. What are these two questions about? They're about big mass, some of you will know it's Bob mass, big mass, order of operations. 4 multiplied by 2 is 8. Got our plus sign there, but we've still got to do our division because the order of operations says we've got to deal with the multiplications and divisions first. So 8 divided by 4 is 2. 8 added to 2 gives us a result, a solution of 10. Big mass, brackets first. 4 minus 6. So inside the bracket we've got a value of minus 2. Big mass then says indices next. So we've got a squared, minus 2, negative 2, squared. So that's minus 2 multiplied by minus 2 gives us a positive result of 4. Now we can do our addition. 10 added to 4 gives us a solution of 14. Expand. Everything inside the bracket has got to be multiplied by what's outside the bracket. So 8x multiplied by x gives us 8x squared. 8x multiplied by 2 gives us plus 16x. Job done. X plus 3 and x plus 2 in two brackets next to each other. Some of you will have been taught a method of FOIL. First terms, outside terms, inside terms, last terms. First terms, x times x gives us x squared. Outside terms, x times plus 2 gives us plus 2x. Inside terms, 3 multiplied by x gives us plus 3x. And last terms, 3 multiplied by 2 gives us plus 6. We can bring together the like terms there to give us an overall solution, x squared plus 5x plus 6. Evaluate 3 cubed. 3 times 3 times 3. 3 times 3 is 9. 3 times 9, 27. A number worth trying to keep in your heads. 15 squared, a number that comes up regularly in GCSE calculations. 15 times 15. The result is 225. Definitely a number worth trying to remember. Factorise. What is common to these two terms? The only common factor to those two terms is a 5. 5 times what takes us back to 15x. It's 5 times 3x will take us back to 15x. 5 times what will take us back to minus 5y. It's just a minus y. A quadratic expression that needs factorising. So 2 brackets. An x at the front of each bracket. What two numbers multiply together to make minus 24, negative 24? what two numbers add together to make plus 2. That being a negative 24 means that one of the numbers must be negative, one of the numbers must be positive. The fact that they add together to give a positive means that the positive number is the greater in magnitude. So two numbers that work is plus 6 and minus 4. Plus 6 multiplied by minus 4 gives us negative 24. Plus 6 added to minus 4 gives us a plus 2. Solving, x equals, balancing both sides of the equations. We want to get the x on its own. First thing we do, subtract 7 from both sides. That leaves us on the left hand side with 5, and that equals 5x on the right hand side. Divide both sides by 5 to get our x on its own. X equals 1. Let's have a little look. 5 lots of 1 gives us 5 plus 7. Yes, it takes us back to our value of 12. Balancing both sides. Subtract 2x from both sides. That leaves us with 3x on the left hand side minus 11, and that equals 4. So we've got our x's onto one side. That's the start of our process. Now add 11 to both sides. Now we've got 3x on the left hand side equals 15. Divide both sides by 3, leaves us x on its own, and x equals a value of 5. Calculating the value of x, this angle x. We've got a triangle. We know one angle. What's that angle? It's 90 degrees. We haven't got enough information yet to calculate our value of x. 180 degrees inside a triangle. What we have got though is this 120 degrees on a straight line. What do angles on a straight line add up to? They add up to 180 degrees. So this angle here must be 60 degrees. This is 60 degrees. This is 90 degrees. We've used up 150 degrees out of our 180 degrees for a whole triangle. So it means that x is going to have a value of 30. X is 30 degrees. Okay, that brings our starter to a conclusion. Now we'll move on, just a little bit of revision from yesterday's lesson about some terms involved in circles. So a little bit slightly different. We talked about radius yesterday, very important term. Centre point of a circle. Any line drawn from that centre point out to the circumference is going to be a radius. That means this area here that's bounded by those two radius, that's known as a sector. That's an important word for you to remember, sector. Another word that you need to remember, the line that goes from the edge of a circle and joins the circle again, so it goes from edge to edge, finds an area, that area is known as a segment. So that is a segment. That line is known as a chord. I'm going quickly through these. We will go through these as the week goes on. Okay? So the idea of a sector, which is bounded by a radius and another radius, and then a segment, which is just part of the circle, the inside of the circle, and it's bounded by a chord. Other terms that we need to remember in particular, I've spoken about already, the idea of a radius going from the centre point out, sorry, that didn't look too good, centre point out to the circumference, the outside of the circle. Don't forget that circumference is that special word for perimeter of a circle. So that's the radius. The line that goes from one side of the circle through the centre point out to the other side of the circle is known as the diameter. So we've got a radius, we've got a diameter. Why do we need to be really confident and assured about those? Because we need to consider those when we go back to our formulae that we discussed in yesterday's lesson. Circumference of a circle, there's two formulae for the circumference of a circle. Finding the distance round the outside of a circle. Circumference, that special word for the perimeter of a circle. Either pi times the diameter or 2 times pi times the radius. Area of the circle is pi r squared. So you've got to be confident you understand the difference between radius going from the centre of the circle to the outside and the diameter that goes all the way across the circle through the centre point. We looked at semicircles in yesterday's lesson. We were talking about the area. The area of the whole circle would be pi r squared. So what's the area of a semicircle, which is half a circle? It's the area of the whole circle divided by 2. What about a quarter circle? It's a quarter circle. Quadrant, a quarter circle, a quadrant. The area of the whole circle would be pi r squared. To get the area of the quadrant, we divide it by 4. Okay? So the area of the half circle would be pi r squared divided by 2, so halve it. Pi r squared divided by 4 will give us the area of a quarter of a circle. If we have this situation, so we have a shape let's present that a little bit differently actually. We've got a shape and we've been asked to find the area of that shape. What have we got? We've got a rectangle and we've got a semicircle. Can we find the area of a rectangle? Base times the height? Yeah, we can do that. We can find the area of a rectangle. Can we find the area of a semicircle? Yeah, we can. Pi r squared, thinking about the whole circle, and then just halve it. So could we find the area of that shape? Yes, we could. Quite a common exam question is a sheet of metal and we cut out a circular hole inside the sheet of the metal. And the exam question quite commonly asks what is the area of metal that we've got left once we've taken out the circle in the middle. Can we find the area of this rectangle or square? Yeah, we can find the whole of that area. Can we find out the area of the circle if we've got the relevant dimensions? Yes, we can. So we could find the area of the circle, we can find the area of the whole rectangle or square, and then just take away the area of the circle to find what's left, which would be our shaded area. That's quite a common exam type question. So, what I'd like you to do, there's 3 examples here. I'd like you to copy these examples down. Stop the presentation, use your calculator because your calculator will have a value of pi on it. Your phones, if you haven't got a calculator, will have a value of pi on them. Use your calculator, work out the area of this shape here, work out the area of the second shape, work out the area of the third shape. What have we got? We've got a rectangle with a semicircle on the top. What have we got? We've got a triangle with a semicircle on the top. What have we got? We've got a square with a semicircle on either side and on the top as well. So copy those shapes down. Stop the presentation, try and work through those examples and see what you get as solutions. and then I will work them through when you restart your presentation. I will work them through with you. 4.7 centimetres, 4.1 centimetres. 22 centimetres, 16 centimetres. 8 centimetres, 8 centimetres. So those are your dimensions that you need to work with. You've got all the information you need there, so make sure you've got those examples copied down, and then stop your presentation, have a go at them, and then when you restart, I will work through the solutions with you. Okay, working through the solutions for these problems. So we've got a rectangle and we've got a semicircle. So for the area of the rectangle, 4.1 times 4.7. 4.1 times 4.7, base times height, gives us a result. If we use our calculator, 4.1 times 4.1 times 4.7, 19.27. 19.27 centimetres squared. Is that about right? 4 times 4 would be 16. It's going to be a little bit more than that, so 19.27, that's a reasonable answer. What about the area of the semicircle? The area of the semicircle, pi r squared divided by 2. So the whole circle would be pi r squared, but we're only dealing with half of that, so it's pi r squared divided by 2. Pi. What is r? The diameter of that circle would be 4.1 centimetres, so the radius, the value of r, is half of that 4.1. So it's 2.05 squared, and then divided by 2. So let's do that calculation. So I've got 2.05 squared multiplied by a value of pi, and then divided by 2. Hold on, went a bit wrong there. Let's just try that again. 2.05 squared multiplied by the value of pi, and divide that by 2. And that gives me to 2 decimal places 6.60 to 2 decimal places centimetres squared. So for the whole area, 19.27 added to 6.60 gives me 25.87. 25.87 centimetres squared, and that's to 2 decimal places. Okay, next example. What have we got? We've got a triangle. That's easy, we can do that. What's the area of a triangle? It's base times height. So 16 for a 16 for the height, 22 for the base. So we've got 22 times 16. Don't forget it's a triangle, so it's half of that, half of the base times height. So that gives us a result of 176 centimetres squared. So that's the triangle. The area of the semicircle equals, now it's a half, times pi, and what's r? The diameter, the whole way across the circle, would be 22 centimetres. So half of that, the radius, it's going to be 11. So it's 11 squared. So we can put those figures into our calculator. 121 times the value of pi, and then divide that by 2. That gives us 190.07 centimetres squared. That's to 2 decimal places. Okay, so our total area is those two added up. 176 plus the 190.07, which gives us 366.07 centimetres squared. Okay, that's the second example done. So the final example, the third example. Now what have we got here? We've got a square, and we've got 3 semicircles. Now each of those semicircles is the same size, diameter of 8 centimetres. Each of those semicircles has got a diameter of 8 centimetres. So let's do this. Let's work out the area of the square, which is just 8 times 8. So that's 64 centimetres squared. Now each of those semicircles, don't forget there's 3 of them, we mustn't forget that, but each individual semicircle is going to be a half times pi times r squared. Now the diameter, the d, is 8 centimetres all the way across. Half of that, the radius, is going to be 4, so it's 4 squared, which we know is 16. So for each of those semicircles, our area is going to be, let's see, 16 multiplied by the value of pi, and then divided by 2. So each semicircle is 25.13 centimetres squared. That's to 2 decimal places. So that means we've got 3 of those. Don't forget, we've got 1, 2, 3 of those semicircles. So our whole area is going to be the area of the square. So 64 added to 3 lots of 25.13. So that's 64 added to 75.39, which gives us a solution, an answer of 139.39 centimetres squared to 2 decimal places. That's your 3 solutions. Okay, that's your main exercise for today. There is an exercise on sound learning for you as well, a very brief one that's just revising general terms, one that's talking about doing some little calculations for you. And just to finish off, just a little bit of extra catchphrase. What well-known phrase or saying is that going to suggest to you? A couple of words written there. What does that suggest to you as a well-known phrase or expression? I'm not going to tell you the answer today, I'll tell you the answer tomorrow. Got another example though. Ooh, that one's a little bit more complicated, isn't it? There's definitely the word road there, and then you've got something else. What well-known phrase or expression or name does that suggest to you? So we've got 2 examples there. First one, we've got the word ground and we've got the word London. Second example, we've definitely got the word road, but there's something more to it than that. give you those answers with tomorrow's lessons. Hope that's been useful. Not quite as much for you to do today. There's no separate worksheets on the Show My Homework, so you've got presentation to look through, the work to be done off the presentation, the 3 examples for you to do when you've done your starter, and then there's a little bit of SAM learning for you to look at, but not too much. Thank you very much for your attention. Stay healthy.